Okay, this is number 8 for our chapter 3 and 4 review. The directions to this one read, find a polynomial function of lowest degree with rational coefficients and the following as sum of its zeros. And the two zeros that we are given are negative 10 and 3i. So the first thing that we have to determine is whether or not there are additional zeros. Okay, we have to determine if there are additional zeros. Now, negative 10 is the first zero that we're going to talk about. Negative 10 is a rational zero, and if you remember, rational zeros do not travel in pairs. What that means is we do not have to have the opposite or the conjugate of negative 10. Negative 10 stands completely by itself. So if negative 10 is the solution, x plus 10 is going to be the factor. So x plus 10 is one of our factors when negative 10 is one of our solutions. The next solution that we're going to talk about is positive 3i. And positive 3i is a complex or imaginary number. And imaginary numbers have to also have its conjugate. So if 3i is a solution, because it's imaginary, it travels in pairs, and so negative 3i has to also be a solution. So if I go back and I look at the factors that's associated with 3i, the factor that's associated with that is x minus 3i. And if I look at negative 3i, since negative 3i is a solution, the factor that is associated with negative 3i is x plus 3i. So, just as a reminder, negative 10, positive 3i, and negative 3i, those are the solutions. X plus 10, x minus 3i, and x plus 3i, those are our factors. And there's always a relationship between our factors and our solutions. Now we are going to multiply our factors together. This is one of the situations where we are working in the opposite direction. We go from solutions to factors to the polynomial. And in the past, we've gone from our polynomial, we have factored it, and gone to our factors, and then from the factors we would go from our solution. So we are working backwards in this situation. The first thing that we're going to do is we are going to FOIL our x minus 3i and our x plus 3i. It's always a good idea to FOIL those conjugates first because we use the difference of perfect squares and we get a nice rational number that goes with that factor. So always FOIL your conjugates first. So I am going to FOIL the two that I have highlighted, and I'm going to get x squared. Then I'm going to get negative, or actually I'm going to get x times positive 3i, so that's going to be positive 3xi. Then I'm going to have negative 3i times x, and that's negative 3xi, and that's exactly what we want right there in the middle. We want those to cancel out. Then I'm going to multiply negative 3i times positive 3i, and that's going to give me positive 9i squared. And actually I made a mistake right there, so I need to fix my mistake. It gives me negative 3 times positive 3. That gives me negative 9i squared. So we are going to fix that mistake right there. So negative 9i squared. And some of you may know why I made a mistake there. I got ahead of myself. So that I squared is going to become negative 1, and then we're going to have negative 9 times negative 1, and that's going to give us positive 9. So that's where my brain was going right there. So, but first I'm going to go ahead and cancel out our middle terms, our 3xi and our negative 3xi. So I am left with x squared minus 9. Our I squared becomes negative 1. So then I am left with x squared plus 9. And so we have a nice binomial that we can FOIL with our other binomial. So we have x plus 10. So now we are going to take x plus 10 and we are going to FOIL that with x squared plus 9. And we're dealing with all rational numbers here now, so we don't have to worry about any conjugates. So I'm going to have x times x squared. That gives me x to the third. Our outer terms are x times 9, so that is going to give me positive 9x. My inner terms are 10 times x squared, so that leaves me with positive 10x squared. And then I have 10 times 9, which gives me 90. Now look for just a second right here. I have 9x and I have 10x squared. It's not incorrect to have it written that way. It's just not how you typically see it. Typically you see it with the x to the third, and then your x's go in decreasing order. So I have x to the third, then I have 10x squared. Okay, x to the third has a degree of 3. 10x squared has a degree of 2. So you typically see that with your your exponents that are associated with your x going down. So our next one would be 9x, and our final one would be 90. So this right here, x to the third power plus 10x squared plus 9x plus 90. That is our final answer for this problem.